Good morning, everyone. As Karen said, thank you. This is about object level analysis for level information need. And I will present this on behalf as well of my co-author, Marzia Bolpagni, who sadly would not be able to join us today because she's busy receiving another award. So the problem really about why this matters is that there's two standards that really tell us about the structure information requirements, which are the ISO 9650 series and ISO 7817-1. And it basically determines information requirements into three big categories, which is alphanumerical, documentation, and geometrical information. And you want to organize them by purpose. And the problem is that once you have to coordinate such a model in a construction project, it becomes to the point where you really have no real single purpose model. It's always a multi-purpose model where objects become a little bit too complex to coordinate because information duplicities and certain other issues have to serve a lot of different purposes like design coordination, compliance, energy analysis, cost estimation, construction planning, and whatever else that you can think of. And here's the gap. Really, at the moment, there's not such thing as an analysis of this kind of impact in terms of how do we define purposes across multi-purpose models. And that's what we wanted to understand is, well, if we see practice and we understand how practice is being done today, you end up with models that have a lot of duplicities in terms of information, clashes that basically information is provided by different stakeholders, and decisions that are driven basically based on experience and not necessarily on evidence regarding how do we specify information requirements. So I'll try to work around that. We ended up framing 5 research questions. The first one is really how information specifications and requirements vary across object purposes and phases. The second one is about how we distribute those geometrical, alphanumerical, and documentation requirements across purposes, basically to understand where that kind of information specification is actually required. The third one is about which objects actually carry the most information burden. The fourth one is about whether those individual objects support multiple purposes or they are just specifically attached to a specific purposes. And the fifth one is about whether the information specifications are actually unique to certain purposes or where those duplicities actually come from. So we ended up using Beam IDS as our data source because we believe that it was one of the easiest and open source databases of data that could actually talk about object in depth, in granularity, at the same time that it was both applied to 7817-1 and 19650 series. And basically, it was perfect, if you want, for the analysis that we wanted to make. So in the end, we ended up with around 5,000 requirements across 80 objects, 22 purposes, 5 phases that we mapped because we are from the UK, so to REBA, but that could be changed. And in the end, you end up with about over 2,600 triples that contain, or different triples that contain that object to phase to purpose combination. So we do end up doing some descriptive analytics, some correlation analysis, some consistency analysis, some principal component analysis to understand the framework that we're trying to present, and some temporal profiling. So the framework is like this. We presented basically 3 levels of KPIs where we understand based on those numbers, I would say, because most of them are numerical, what the consequences of identifying and selecting certain types of specifications and purposes have at the purpose level, at the object level, and at the combination of both. I'm not going to go in detail about the purpose and object levels because I don't have the time, but in terms of combination, that is where we actually look into the uniqueness of information that is provided by adding new specifications and requirements. And on the other side, whether it is really valuable to add additional requirements based on its marginal contributions. So the first finding that we got is that if you analyze the way that purposes are defined by Beam IDS, there's clearly 3 types of archetypes that show up very quickly. There's very geometrical dominant types and purposes. There's very clear alphanumerical dominant purposes. And there's clearly one documentation dominant purpose, which is surprisingly documentation. Minimum requirements. So in the way that it's defined, it doesn't make much sense in the way that BIM-IDS considers that all documentation available needs to be provided as minimum requirements, but that's what it is. And the idea is that there is specifically, when you select information specifications, 3 types of really purposes that you need to identify, and that will be the burden that you actually are providing to your model. The second part is that there are specific objects that are or play as integration points for your model. And that means that when you actually have doors, for example, in your model, they are the most intense data source for your information requirements. They have the capacity of having up to 172 requirements across 16 purposes, which means that when you think about quality control and coordination in your projects, those are one of the key aspects that you need to consider, because they are the ones that will have the most capacity to obtain or have clashes in regards to conflictive information. And you go down the text that I put there, doors in the bottom, but you see windows, ramps, space, slabs, wells. So the most common objects that are in our models that will have the most likely issues in regards to coordination. In terms of phases, there's not much to say beyond something that is quite common, which is information increases as we go towards the construction phase. And but at least it's nice to see that we can now quantify more or less what is that information increase and the requirement increase based from, for example, the jump between the strategic planning of the project in phase 1 and the spatial technical analysis or conceptual design in phase 2, which is almost 300%. And that means that we can understand phases as a way to specify efforts in regards to information management and coordination much more than thinking about whether it's going to be affecting us or how is it going to be affecting us. But really, you can get some numbers down there. We validated the framework, so the 12 KPIs, using 2 things. One of them is we wanted to run some correlation analysis to understand and make sure that our variables were independent. And most of them are, except the ones that we already know that are not dependent, because if you look at the equations, they depend one on another, so that was expected. But most of them are actually low to moderate in terms of correlation, so that's good. On the other side, we have principal component analysis, which identified basically that the 3 archetypes that we were talking about, so the geometry dominant purposes, the alphanumerical dominant purposes, and the documentation dominant purposes are actually independent. So that means that we really have 3 different archetypes, and it's very clear that it's the case. And it's not random. That is actually something that either when BIM-IDS was being created or just the way that we identify information requirements, it really links to purposes being unique, which is really good because that's exactly what 78.7, basically the whole philosophy and principles around that is just because of that. Just identify different purposes that are quite unique to the model. If we look at the temporal archetype, we also see kind of some of the things that I've said right here, right, which is there's a clear curve in terms of information specifications across phases. What is really interesting from the first picture is that if you look at the green one, you will see that it's, the average is the flat line, but you have the variation across the whole thing. And you will see that it's very variable. So it's very dependent on your project. You will have a lot of alphanumerical information or not. And it depends on also your purposes and your selection of specifications. But it tends to be the highest problem around coordination, where you would have maybe a phase 1 project where you would have 0 or you would have 100. So it becomes a very variable system. In the end, we created a dashboard that basically allows you to play a little bit with understanding how information requirements and information specifications affect your future model. And we will make this dashboard available after the conference. somewhere in a website or providing by the HTML through GitHub. The other thing that is very interesting is that you can also upload your IFC file or your IDS specification, and it will suggest, basically based on the KPIs that I've mentioned, suggest options in regards to how you want to match the specifications that you want to certain purposes, or the other way around, if you have purposes, which IFC information should be available in your model. In the end, to wrap up, we found 3 purposes archetypes and validated them through both PCA and temporal signatures. Universal objects are integration points in specifications. So we span a lot of different purposes, and that's where information quality management should focus. Crucially, uniqueness is high, which challenges the assumption that a shared baseline can serve everything. It's generally distinct information, and it validates actually the purpose-driven philosophy of 7817-1. And the framework is source agnostic. So if you have other types of data sets that are structured to the standard, like they provide the purpose phase object combination and triples, they can be used through this framework as well. So I'll be happy to take it and then maybe add it to the data set. And that's it from me. Thank you very much.